Okay, yesterday we left off talking about the equalizing circuit. And I said in a multi-engine aircraft, if generators are not paralleled, one generator does all the work. Well, that's not good. So you have to parallel the generators. So they often have, so what you do as a mechanic is you're going to get them very close. And then an equalizing circuit will take care of just the final little differences between them.
Do you ever have to mess with the equalizing circuit?
I've never had to.
Okay.
Which is not to say you may not have to, but I've never had to. But like anything, you can go out. So an equalizing circuit, and equalizing circuit keeps the generators matched. And that procedure is called paralleling. I'll write that for you. The procedure for matching is called paralleling. Paralleling the generators. All right. So far we've talked about the voltage regulator, and then I touched on the equalizing circuit, which matches the voltage so that the current will be the same. And now we're going to move on to another part of the voltage regulator, which is the reverse current cutout. Reverse current cutout relay. Now, what do you suppose the reverse current cutout relay does? Hey, if the current goes in reverse, it's going to open. Going to cut it out.
Hey, cut it out.
Open.
Don't make me stop this car.
All right. Reverse current cutout. So here's just a simple version of a reverse current cutout. And let me say, I got to pick a cool pen.
Rainbow.
I don't think I can do rainbow. All right. So we have the generator. What is this part right here? Field windings. Field windings are looking for, this is the just now voltage regulator in a box, but we know how it works inside. The F is going to what? This is F plus. I think it's B type. All right, doesn't really matter much. Okay, so at this point, so we have output of the generator coming to A. Okay, it's going to go off here to the voltage regulator, which controls the field strength. Oh, the field, since the field is grounded at this spot, it's what type then?
B type. Looking for batteries.
It's looking for batteries, so it's got B type. So F plus, not F minus. So it's looking for battery. That's material. Yes?
Is that like in that sort of circuit? Is that the telltale sign? Is it that F is plus?
I
Or
wouldn't
B type?
trust it like that,
Okay.
because some of them are just marked F. So, all right, so what's going to happen is the generator starts up, and right now it's, make sure I go the right way. Okay, it's going to come to this point. Inside of the reverse current cutout relay, there are two coils. You can't always see them, but they're there. Sometimes one is inside of the other, and all you see is the very fat one on the outside. Notice they even have the thicker wire right here, indicating a much heavier wire right there. So very thin wire. It's going to come down through here and wrap its way around this coil. Is this in series or parallel with the load? Is it going to the load? No, so that make it series or parallel to the load? Parallel. Okay, so is this going to be a very small wire or a very big wire?
Small wire.
Very small wire. It doesn't have much current going through it. It's just got some. Just enough to do what? Well, as this builds up to whatever it's set for, and we'll say that it's set for set for 14 volts right here. Whatever it's set for, then when it sets to that, it's going to have enough electromagnetic force to close the points. Well, once the points close, we're now going to have current flowing through here, through the closed points and off to the aircraft. Is this in series or parallel?
Series.
All right, it is in series, so that wire must be
Big.
pretty fat because all of the current that's going from the generator to the aircraft has to go through this. All of it. Not some, all of it. So off it goes to the aircraft and everything is fine. Well, at some point, we're either going to shut down the generator or perhaps we've done something where the generator is not able to maintain its voltage above the battery. So if it drops below the battery voltage, like we shut it down or something like that, let me see if this will work. Go blue maybe. So the battery is going to start feeding back through this coil backwards. And as it does, it causes a reverse of the magnetic polarity. And instead of pulling the points, pulling points down, it pushes them up. And when it pushes them up, it turns off the, I don't know how to do that. It turns off the current going through because the point's open. Point's open. There we go. Point's open. Follow that? Oh yeah, so one more time, but I'm not going to do it. Drawings. So, generator starts. Voltage goes to the voltage coil, which is very small. When the voltage builds up to the point where it is to its set spot, which should be set higher than the battery, the points will close. When the points close, all of the current going to the aircraft goes through the current coil, creates a magnetic field that pulls the points down even tighter. So the magnetic field now is going down, pulling it tight, and off to the aircraft. Shut down the generator, or if the generator output is less than the battery, current starts flowing that way. If current flows that way, it'll flow through here, start flowing through here back to the generator, and when it does, it reverses the magnetic polarity, which is stronger than the voltage coil, and opens the points. Not so hard, was it? Questions on that?
Wait,
Yes.
Just real quick, so you said the current coil is in series with what?
The aircraft load.
Okay.
Kevin,
Yes.
when you're starting a generator and it's building up to the 14 volts,
Yep.
all the current is going through the smaller.
Very little current is flowing. Very little. Just enough to go through this voltage coil. So, not much. Just, I mean, it's tiny little coils. Tiny. Well, I guess as far back as I go. All right, so let me see. I could write reverse current cutout. Reverse. Ooh, I wrote reverse current cutout. I'm doing it again.
Field
How
coil.
many times are you gonna say it?
I know why, because that's not F. That should be, I made it 4.
Oh, wait.
There.
14, 4?
Now, in every system that has a generator that charges battery and supplies aircraft power, there must be an automatic means to disconnect the generator from the battery if the battery voltage is higher than generator. In every system, I gotta shorten that up. System, there must be an automatic, I want to say that. Automatic, I'm out of room there. Automatic system. Nah, I don't want to say system twice. An automatic way to disconnect the battery if generator voltage falls below battery voltage. let's see. The reverse current cutout relay, there we go, uses 2 coils, 1 voltage, and 1 series. So, or 1 in parallel, 1 in series. On the same core. I can do that. Kind of short. When preset voltage is reached, reverse current cutout relay closes and current flows to the aircraft. So far, so good? All right. If or when if generator voltage falls below battery voltage, reverse current opens the points. All right, so I said that I tried to be a little fast about this. One thing I'm missing in my notes here, though, that I did mention. So, reverse current cutout uses 2 coils, 1 voltage, 1 series on the same core. When a preset voltage is reached, the reverse current cutout closes and current flows to the aircraft. That's very true, but also it creates a magnetic field in the larger, fat series windings that brings the points, it helps close them. So it works with the voltage coil. When current reverses, it reverses the polarity of that coil, which overcomes the voltage coil and opens up the points, and then everything stops.
But when you say when it reverses, it doesn't have to be repolarized or anything?
The generator?
Yeah.
No, you don't have, because
It's not like reversing polarity.
well, that would be like every time you shut down the engine, then you'd have to take off the generator and flash the field.
Yeah.
Yeah, well, you don't have to take it off, but no, so you don't do that.
It just kind of flows backwards in a sense.
It does flow very much backwards through that coil and pops it open.
Okay.
Let me see.
And the 1 series you're talking about is the one that goes to low?
The what?
The 1 series coil you're talking about is the one that goes to low?
Series goes to the load.
Okay.
All right. I'm going to put them all together here in a minute. So, current limiter. Current limiter is the last one. Current limiter. It is also a vibrator type. Vibrator type points. It is supposed to open when a preset current is met. So, designed to reduce generator output, or hold it at a max output if max current is reached. So generators are rated at a certain amperage. I think I knew what this one was at one point. It's on there somewhere. That's like, I think, 20 or 30 amps. So if you exceed the amperage, it starts heating up. And we talked about that. And it's spinning and it's heating up and starts flinging solder out and ruins it and melts wires, and then it's gone. So you have to have some way to limit it. Otherwise, what would happen is you could just put on all these different loads, and if all you had was reverse current cutout and you had a voltage regulator, reverse current cutout saying, well, I'm happy, it's as long as we're not going backwards, it doesn't care. And the voltage regulator's job is just to give it voltage. And so the more loads you put on, the voltage starts to drop, and then the voltage regulator is just going to close and vibrate slower and say, well, let's give more field current. Let's bump it up. And it would just keep doing that until it couldn't anymore. But if you've seen when I run the generators with you guys, I'll momentarily ground out the field, and you see the voltage. I mean, it just spikes out and amps goes crazy. So even those little generators, I mean, they'll put out, I think, 100 amps for a while or more. I haven't really done it to see how far it would go, but it goes up fast. So, all right, so you want to do that. Designed to reduce generator output if max current is reached. Yeah, excessive output will lead to overheating. Overheating causes solder to fail and windings to come undone. I'm going to write that because I think it's a test question. So B1. And I roll up. There we go. Excessive output will lead to overheating. So excessive output will lead to overheating. Overheating. And overheating, that causes solder to fail. Solder to fail and windings to come apart.
Where's the heat ready for the solder?
I do not know.
As hot as the salt.
Let me think here.
Hot and melt.
No, it's not supposed to melt. Wired in series with generator and aircraft. Or load, I should say load. Load or bus. All right, you write some notes.
Hey,
Back?
no, no.
I don't want to go back now. Let me see. First current cutout. Didn't we just do that one? Got that right. Current limiter. There we go. All right. So you want me to go back to this and chill for a minute?
No, I got it.
Well, yeah. After all that complaining, I'm here.
Well, he helped me out. He did me a solid, unlike somebody.
So I'm free to move.
You can do whatever your heart desires.
Really?
Wait, go back.
Keep it there, kid dog.
Okay. So pick a color.
Rainbow.
I don't think I have a rainbow here.
Every color.
Rainbow. Red.
Okay. What do we have here? We have a current limiter circuit. So again, what we've done, we've taken out the other circuits. So we have voltage regulator. Somewhere around here's reverse current cutout too. So what happens is current is going to come through this way. This is a normally closed circuit. Normally closed. So this is, hey, thanks. It even says that. Thank you for saying that. So if it's normally closed, it's going to be normally closed. It's in its relaxed state. Nothing's been on. So go back to color here. All right. So normally closed. Even when the aircraft is off and it's sitting there, this is closed. So we start up the aircraft, generator builds up to its correct voltage. Voltage regulator starts vibrating, keeping it at the right voltage. Current flows through and, oh, I'm sorry, this is reverse current cutout. I need to go this way. So I didn't realize there was one. So it just comes through the closed points, and I just blew that all to heck. This is not what I was looking for. I don't like this one. Current limiter. Doesn't look like that. Skip it. Here, if you don't like it, just move on. All right, this one I like. So let's put them all together, and we're just going to see how it works. So first thing is, well, we got to get out. We should let yellow be voltage. How about that, since I already got the yellow pen? So in our normal relaxed state, all right, let's take a look at where things are. Voltage regulator. Should it be open or closed? Normally open or normally closed?
Close.
It is, in fact, normally closed. All right, so voltage coil, so it's normally closed. Current limiter, normally open or normally closed?
Close.
Closed. Okay, so again, this is being in the off. Make sure you're taking notes here because I'm not going to go, I don't have time to write all this down. Reverse current cutout, normally open or normally closed?
Open.
Okay, so that's normally open, NO. And this one's normally closed. And this one's normally closed. So you should just make a sketch of this real quick.
Take a picture, it'll last longer.
All right. Back to my highlighter. Okay, so we start up the aircraft, and what do we have in? What type? A or B type?
E-type.
B type. Why is it B type? The field is grounded internally, and F needs battery or a positive. Armature works well. All right, so we start up the aircraft. We have some current's going to flow through here. It's going to go down to the voltage coil. And it should find a ground, should have a path going out. There it is. Okay, finds a path, goes around. Technically, this is its path like that. So, so the voltage coil then, when it builds up to 14 volts, sorry, did I say this was normally closed? All right, so so as it builds up, and the voltage exceeds its set limit, what's it going to do? Well, briefly, what does it want to do? It's going to have a pull going that way, and it'll pull this open. Okay, but while it's closed, now we have full, let's see. This one's just a little more complicated. Field. There we go. So we have current flowing. Here we go. This way. Joining it up through the resistor, back around, resistor, going through the field. All right. So when this opens up, it's going to kill off that, so to speak. It's just going to go through different resistors. But it's just easier to say it kills it off. So it's going to go through different resistors or diminish that so that we reduce the field current, field strength. What happens to the output of the generator? Okay, it decreases. So, oops, I didn't mean to do that. So when there's not enough not enough output of the generator for voltage, we have a higher field. Yes, when there's not enough output voltage-wise, it increases the field to increase output of the generator voltage. When the generator voltage exceeds what it's supposed to, it doesn't want to do that.
It makes noises.
It makes noises.
Open the points.
Open points. All right. All right. So points. So the points are going to open and close, adjusting the strength of the field. All right. So we've got that going. Now let's pick up a green here. So we'll go. Oops. All right. This wire here, as it's represented, is rather large. So when we reach the proper voltage, actually just right away, we're going to have current coming through, headed off to which device? All right. This one is drawn a little bit different than some of the other ones, but we'll go with it. All right. There's different styles. So, all right. So this is going to come through, and this is normally open, normally closed. Normally open. So it's open right now. It's not doing anything. What's going to close it?
Reverse.
All right. Remember, there's two coils on this. We got to find some voltage. So this is going to find its way back to ground. Yes, it does. So current's going to flow through here, find its way back to ground, and when it does that, it's going to close this coil, and when it closes that coil, current is going to flow out to the aircraft electrolytes. There it goes. All right, so it's running fine, but we start to exceed what should happen with amperage output. Now, some of them I've seen where they actually open up a circuit right here. All right, but this particular one's not that way. So when this exceeds a certain amount, what's it going to do? So it's going to open this up right here. What happens when it opens that up?
Just go to the resistor.
Well, if we really want to study this particular style, we can see that there was a path through here around. So I can find a path with very little resistance. I have one resistor there. Doesn't give me the resistance of the resistors. But what it's going to do is open it up. And so instead of sending current through this way, it now has to go through the second resistor, which diminishes the field strength. When it diminishes the field strength, the output decreases. Right? That's all you got to figure out. So this is the tricky one over here, just because it has 2 coils. And so we shut down the aircraft, and current starts coming back through this way. Once it gets in here, it's going to open the points. It shuts that down. No reverse current anymore. You're done. Questions on that? Matt?
So the current limiter,
Current limiter.
can you go over that just briefly? So it has voltage rolling through it.
No, the actual current coil is fat, so it doesn't have voltage going, nothing has voltage going through it.
Okay.
It is in series with the load. So everything that the generator puts out has to go through the current coil and out.
Okay.
So
And that exceeds, it's going to open, and it's gonna find, and then the
it's going to open this.
voltage will have to go through the resistor instead of the
Yep.
easy path,
Yep,
which will cut it off.
yep.
Okay.
Will diminish the output.
It'll decrease it. Yes.
For the reverse current relay, you said when you turned it off, and if you have excessive current coming from the other side to,
From the aircraft battery back to the generator.
yeah, you said it opens the points, but the points are normally open, so when you
Well, they got closed when we started up the aircraft, and it reached its voltage. The voltage in this coil right here, this yellow part, that's in parallel. So the little windings sensing voltage closed it, and then all the current that started to flow through the upper coil, the series coil, really held it closed. So you have not only the yellow coil, but the green coil both trying to close it. All right? Now, when you shut down the generator, or the voltage falls below the battery, the current flows back through it this way, and instead of having a coil that is pulling down, it turns into a coil that pushes. And because this coil has so much more powerful than the yellow coil, so to speak, it pushes it up, regardless of what the yellow wants. The yellow just doesn't have enough power.
If you don't have voltage in there, then the spring, the tension is gonna open it, right?
Yes,
So when you shut down the system, it should just open.
it should, but it's just an easy way to say that. Okay, but how about if I'm idling and the output then is only 6 volts on a 12-volt system?
Then it's gonna be.
So every time I pull back to idle, especially in a generator, they don't charge at idle. They have kind of a high coming in speed, about 1500 for a lot of them, 1200, 1500. So you're idling, you're well, I can see 6 volts. It's less than 13 volts. So you're in trouble. So every time I pull back to idle with the generator, I'm going to have this reverse coming back in.
It's gonna start discharging the battery, right?
Starts discharging the battery. Well, it tries to make this into a motor.
Yeah.
Not a very efficient one. Yeah.
So if your voltage regulator failed, the rest of the circuit is no longer.
Well, what ways it fail? Like it doesn't, like this wire right here is open.
Yeah. Yeah.
Yep, you're pretty much toast. Because then, great question. If you lose the voltage coil, what is generator output? No, it's not zero.
14.
What?
Wait, what?
It's still gonna put out current.
Some. How much? How much voltage do you think I'd get out of this without a voltage coil?
At what RPM?
Wide open.
14.
it's close.
No.
Close.
Zero.
No.
No.
Wait, Josh has got it. Come on, Josh.
Well, it would keep getting
Up and down.
worse. It would keep increasing the field coil.
Nope.
Based on the residual magnet.
Shut down. Oh, right. It's
Better
the
study
One.
1. Very close.
Yay.
Yeah. Probably 3 volts.
Really?
Why?
Doesn't have a load?
Oh, there's plenty of load. All right, so let's follow this through. Let me see. Wish I could erase everything really quick, but I don't know. Stroke eraser? I don't know. Hey, that fast enough. All right, this is exactly where you need to be going with your generator knowledge. Pick a good color. This is an A type or a B type? So it's B type. So B means that what? Okay, field, F-I-E, field needs a battery, or armature plus. It needs power from something. Well, where's it getting its power from? From the armature. Okay, well, if it's grounded right here, where's my circuit? So it's grounded here, so there we go. So we just got to find where is it getting its plus from. Well, it doesn't touch there, so it comes to here, and back through here. This is normally closed anyway. So there we go. So there's my circuit. All right, but I'm saying that the voltage coil died. So if the voltage coil died, so this is normally open. Jeez, why did I draw it that way? No, wait a minute. It's not normally closed.
It just looks open.
Yeah, I don't like that I drew backwards. Okay, so normally closed. Most of the time when you lose these wires, you lose them kind of in here too. So if this was normally closed, just want to think this through, then you could have a problem.
Why are you going through resistor, not through the current coil? Because current coil is normally closed too. So the resistor...
Well, because I don't have to. That's why. I didn't have to. I was trying to make it simple.
It's a more easy way to go.
But now I'm just making it more complicated. So do your way. I'm doing it my way. The question is, what happens if we lose the voltage regulator? Well, okay, so it's going to depend on where you lose the voltage regulator. So if we lose it right about here, or we can go with that. So if we lose it here, do I have any current flowing through the field coils? I have nothing flowing through the field coils. If I have nothing flowing through the field coils, what kind of output do I have is the question. Well, what do I still have remaining here?
Magnetic field.
I have a magnetic field, which self-excites it. So if it's purely running off the magnetic field, you can figure just about a couple of volts. All right. What else do we need to know about that? We good with that?
The current.
What's that?
What if you lose the current?
Well, then you could accidentally get it. You could overboost it.
Kevin, if this is a type A, like how would, like what changes will be there?
What's that?
How will this look for a type A?
That would be easy. Just bring this up to here. So now it's already getting a positive.
Okay.
And instead of bringing it back through to here,
That's
you
it.
just need to bring this over to I can't redraw with this, but the positive goes here, and this F just needs a minus. So you can actually that's I think why I don't like this is because you guys are working with an F type and an A type, and all of this stuff just goes to ground. It just opens and closes at ground, which is what I probably should do, is find one that is a little bit easier for you to work with. And therein lies the problem. So you can just simply you can make it so much more simplistic. This is a little more difficult to explain. So it just goes to ground. Just open and close the ground to here, and you're done. So, all right, let me think, where are we going to go from here? To notes. Well, I don't want to write all of that. Let's see here. All right, so things that we really want to know about that. One, make sure you understand how the generator control works. Even though we covered the A type, we covered the B type. The one in lab is A-type, so make sure you understand that. I'll change that. There we go. I'll change that for next year, but there you go. And one of the big troubleshooting things we come up with is if your voltage output is 2 to 6 volts out of a generator, what are you running on? Not running on battery. Why would you say? Don't say battery. Residual magnetism. Do you need a battery for a generator to operate?
No.
Nope. So could I, in fact, take the battery out of the aircraft, hand prop it, and just go flying and have all my electricity?
Yeah.
No, because wouldn't you just be on residual?
No, what about you?
Battery.
Look at the camera. I can't throw things, apparently.
Good luck. Pause camera.
You have to.
You should, because I'm a terrible throw. I'll hit Matt. Okay, of course you can't do that legally, but, you know,
It's only illegal if you get caught.
it's only, yes. Would it work? Would I have electricity in the aircraft?
Well, yeah, if your generators will function at idle.
How are you gonna start the aircraft?
You hand propped it, remember? I said
Oh,
that.
you said hand prop.
Yes. You're going to push start it.
Off the clutch.
Push start it, pop the clutch. It's the one on the left.
As if you're like in a third world country and that's all you have.
Yes. Okay. Well, then we just went away with that one, didn't we? So,
You're with Duncan.
never mind. Good luck with that test question. Okay. So,
Wait, what?
yeah, I know. All right. So moving on. Is a generator self-exciting?
Yes.
Yes.
Or what is it called, Matt?
What did I say?
What did you say earlier?
Excited? No. What did I say?
I don't know. Probably best we forgot.
Not excited. What is it?
Self-stimulating.
It's self-stimulating.
It is not self-stimulating. It is self-excited is the proper term. What does that mean? What does that mean? Self-excited.
It uses residual magnetism.
Uses residual magnetism. Does it need a battery to operate?
No.
It does not need a battery. All right. So if the battery is 100% stone cold dead, can you hand prop an aircraft and have some hope of the battery regaining some life?
Yes.
Of course, yes, you can. Okay. That's going to be in contrast to an alternator, which doesn't work that way. If you have only 2 to 6 volts output on a generator, max, then what is the problem? Is it an armature problem?
No.
Is it? It could be. But is it a field coil problem?
Yes.
It is something in the field coils. Maybe it's the generator control unit or the voltage regulator, or it's in the field windings themselves. You're running on what?
Residual magnetism.
Residual magnetism. That's how you can kind of troubleshoot these. How are you going to know that you only have 6 volts out?
Your battery's gonna
With a voltmeter. Because if the voltage regulator is working and it's not opening, well, if you only have an ammeter in the aircraft, you're not going to know. So some aircraft have a voltmeter. So if it has a voltmeter, well, you know how a voltmeter works, but some of them have an ammeter. So if your aircraft has an ammeter, it usually has 0 at one end and,
plus and then
plus on the other. 5, 10, 15, 20. And this is negative 5, 10, 15, 20. And the needle, if you start it up and it's got a generator that's only putting out 6 volts, it's just going to stay there on 0. It's not going to do anything until you turn on a landing light. Then it's going to go negative 5. And then you turn on a couple more things. It'll go negative 10 and 15. But it'll never swing to the positive. It's just not going to do that because even though you're putting out 6 volts, it's not connecting to the bus. It's not helping. It's not doing anything. It's just so you have to get out. You have to connect a voltmeter to the actual generator. If the generator is working, when you start up an aircraft, the battery takes quite a beating when you use the starter, especially if you don't start it right away. And you're probably going to see, if your aircraft's been setting for a couple weeks and you start it up and the battery just took a beating, you're going to see 10, 15 amps right away. But you can actually watch it go back to 0. And it'll just take maybe a minute and it'll be just a little bit the other side of 0. Right? So anything on the negative side means the battery's doing the work. Anything on the positive side means the generator's doing the work. once you do start an aircraft up, the battery is part of the load. It's a load. It's on the load side of everything. So that means that it needs to be charged. So that's why you're going to see it over on the positive side. All right. Let's see. Another point here. What if you have no voltage? It's dead.
Armature.
Brushes
Well, of
can
course,
be-
it could be an armature.
or
Probably not.
brushes damaged. The brush-
Could be a brush damage. It's a more likely cause.
Demagnetized.
There you go. Demagnetized. What got demagnetized?
Your rotating magnet.
Rotating magnets got. So you have no residual magnetism. Will it work?
Rotating magnet.
Nothing. You have no, did I say rotating magnet?
I
Yeah.
know.
No, not rotating magnet.
Thinking about
Your-
needles.
You mean the field coil?
Yeah, fields.
How could you lose magnetism?
It goes away.
Over time?
Huh? It diminishes over time.
Like, years?
Depends
I was
on
gonna
the-
say something about that.
It goes away, I get it.
It does. It goes away. Yeah.
How long does that take?
It depends on the size of the magnet.
A long time. So there's a lot. It depends on size of the magnets, what they're made out of, the orientation that's sitting on the Earth.
You know, when you start the aircraft, then it's gonna go to minus your ammeter,
Yeah, as you turn on loads, it'll go to minus.
and you don't have magnetism in your.
Well, it means if it goes to negative, it means your generator's not working. Period. Then you have to get out and troubleshoot it. Hook a voltmeter up to it. If you have 0 volts output, I would suspect that you've lost magnetism, especially if it's been setting for a long time. Now, if somebody said, no, I used it yesterday and it worked fine, it's got 0 output, I'd think something else. But yeah, I haven't used my aircraft in a couple of years, or generator has been on the shelf for a long time and it doesn't work. Yeah, it's the first thing I would think of. So you have to do what's called flashing the field. All right, we talked about Dennis. Oh, jeez. Got him all excited. He's self-excited too over there. No. He's yeah. Talk about self-simulating. So, all right, flashing the field. Didn't I go over this already? Okay, I did talk about it. So, all right, generators can lose their residual magnetism. Magnetism can also get reversed. I can write that. Magnetism can get reversed at overhaul or repair. So anything that might upset that balance, you're going to lose it. Shouldn't happen at overhaul. I mean, let's take that back. Very likely to happen at overhaul, but as you finish the overhaul, you should be reestablishing it. Shouldn't go out of overhaul without it, that's for sure. To correct this, you flash the field. While your maintenance manual that you have for the Delco generator tells you to connect certain things for an A-type, certain things for a B-type, it tells you to do it through the voltage regulator. I highly recommend, and I always disconnect the voltage regulator, get it out of the system. Just remove it, because they break so easy. Those wires are so small. So I disconnect it and then apply the correct, I'll write that, disconnect. This is me, disconnect the voltage regulator. And by voltage regulator, I mean the whole thing. So voltage regulator. And apply correct current. Let me see, apply correct current. Disconnect the voltage regulator and apply correct current to the field. Now, that's going to depend. A type has one and a B type has a different type. So you have to follow the manual on that. So I'm not even going to put it in your notes because I don't want you to follow them and do it. So. All right, let's take our break.